Hello and welcome to the BMC Quick Course series. My name is Andy Andrews and I'm a software consultant for the Mainframe batch products at BMC. Your batch windows are likely getting shorter or disappearing altogether. Concurrent workloads, both batch and online, compete for the same data resources, causing batch jobs to abend because of timeouts, lock contention, and so on. BMC Application Restart Control, also known as ARC, enriches your batch processing environment. ARC is available for DB2, IMS, and VSAM environments. In this session, I'll provide a brief overview of the major functions of ARC. ARC products provide a variety of features to streamline and enrich a batch processing environment. Let's dive into each of these areas. When a batch job fails, you generally recover the affected databases, back out all of the changes made so far, and restart the job from the beginning. This takes time, manual effort, and up to double the CPU usage that a successful job would have taken. In the example here, a job that normally runs in 5 hours could take 16 hours to complete. First and foremost, ARC is a restart product that supports checkpoint restart across many application environments. ARC provides checkpoint restart logic for batch jobs. In other words, it inserts checkpoints or commits at specific intervals. If a job step abends, you simply restart the job at the failed step. During restart processing, the input-output files are repositioned and set to their state as of the last checkpoint. The application program is loaded into main storage, but before control is transferred to the application, the contents of program storage are overlaid with a copy that was captured during the most recent checkpoint. Then ARC transfers control to the application program and execution begins at the top of the program logic. With ARC, you don't need to recover the database and back out changes. Think of all the time and money you can save. Checkpoint processing is an absolute requirement for batch processing in a shared database environment, but it can be very expensive. From the point of view of an application program, checkpoints are 100% overhead, both in terms of resources consumed and elapsed time. In a perfect world, a program would issue just enough checkpoints to satisfy restart requirements and to minimize the number of concurrently held DBMS locks to enable shared processing. However, our world is not perfect. Checkpoint intervals are generally not regulated, and no one thinks about them after the application is in production. Many batch programs are more than 20 years old, and they were written to run on hardware and software that was much slower than the versions we run now. The result is a natural shrinking of the checkpoint interval. What once may have been a 2-second interval over time evolves into multiple checkpoints per second. Most organizations simply cannot afford that kind of overhead. ARC can filter out excessive checkpoint activity without having to modify an application program. The filter sits between the application program and the underlier DBMS. If a program issues checkpoints too often, they are simply intercepted and sent back to the application as though they processed, so the application program can continue to execute. Periodically, a checkpoint will be allowed to pass through the filter and it will be processed normally. The net effect is a significant reduction in overhead on both the application program and on the DBMS. Application Reattach is simply automation provided by ARC to increase the resiliency of your batch processes. When a batch program tries to access a database block that is being updated by another process, the batch program will often abend. ARC Reattach processing will intercept the abend and will redrive the batch program within the same step. Since conditions that cause this kind of transient abend are typically resolved rather quickly, delaying the retry for a few seconds will allow the locks to clear and the batch program can continue to execute. These reattached job steps will eventually end with a zero condition code. In addition to automatically handling certain abends, Reattach can be seen as an enabling technology. As business volumes grow, the time to process them also grows. Eventually, the processing time grows to the point that it causes problems in the batch schedule. Instinctively, update processes are serialized because of the potential for database conflicts. The automation provided by Reattach can be seen as an enabling technology to allow the input of a batch program to be divided and the batch updates can be run in parallel. Any database collisions can be resolved by Reattach. Program exception support, or SOCx, is a variation of the standard application reattach that is designed to deal with bad input data. You can't just reattach, or for that matter restart from an OC7 abend, because you will just get the same bad input record back in and the program will abend all over. The Stop OC7 variant provides several techniques to deal with a SOC7 abend. They are: 1. Ignore the abend and continue with the next instruction. 2. Ignore the abend, zero the result field, and continue with the next instruction. 3. Allow the abend to continue so that the UOW is backed out and then skip the bad record on restart. 4. The preferred approach, same as number 3 above, but write the bad record to a pending file, sometimes called the reject file. Both options 3 and 4 are restricted to a single input file, which must be identified to ARC. ARC brings some special capabilities to VSAM environment. VSAM is used by a great many applications, but since it is an access method as compared to a DBMS like DB2 or IMS, it lacks some of the functionality that DB2 and IMS provide. ARC enhances the VSAM environment by introducing the concepts of VSAM checkpoint restart, VSAM backout logging, and VSAM in-flight backout. In addition, ARC serves as a coordinator to provide synchronization between VSAM data and DBMS-based data. Expanding on VSAM enhancements, ARC provides a very important function called VSAM file sharing. This is enabling technology that allows VSAM files to remain online in update mode to a CIX region while it is being processed in batch. In addition to the file sharing, ARC also provides full checkpoint restart capability to VSAM file sharing applications. This technology provides a very simple and cost-effective way to satisfy 24/7 processing requirements because the underlying application programs can still remain largely untouched. The effort required to implement VSAM file sharing is a fraction of the effort required to convert a VSAM application to DB2. Consider the ripple impact to an application by converting a VSAM file to DB2, not only on the program that does the updates, but on all of the other application programs and CICS transactions that touch the file in any way. ARC provides suspend-resume integration with many of the BMC high availability utility products. The utility products sometimes need exclusive control over a database for a short period of time and will communicate this to ARC. During this time, any jobs running under control of ARC will be temporarily suspended until the exclusive period has ended. After that, they will resume execution and run to normal completion. ARC has been designed to enrich the operational experience of batch programs regardless of the database environment that they utilize. At its core, ARC is a checkpoint restart product, but it builds on this cornerstone to provide a wealth of additional functionality that is focused on enriching the batch execution environment.